Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 2612, Framing diagram. We are given a 0 in this 2D integer array numbers. Return the largest prime number that lies on at least one of the diagonals of nums. In case no prime number present, just return 0. Okay, we want to return the largest possible diagonal value which is also prime. Okay, fine. See here, in first example, this is a matrix. Okay, in this matrix, what are the diagonal elements? I can say this 1, 6, 11. This is one of my diagonal. Okay, and 3, 6, 9. So this is another diagonal, right? Okay, among this, what are the prime? Okay, before seeing what are the prime, we want to do what? What is meant by prime? So we want to know about what is meant by prime, right? Okay, prime numbers are something like it has only factors as 1 and itself. So if it has factors as 1 and itself, it is called what? Prime number. Okay, take for example 2, 3, 5, 7, 11 like this. So these are the prime numbers. Hope you understand this. In this array, what are the prime numbers? 11 and 3. So among this, I will take 11 as our answer because it is a just value. Okay, now in the second matrix here, what is the prime? What is the diagonal first? 1, 17, 10, then 3, 17, 9. Okay, among this, what is the largest prime number? I can say this 17 is the largest prime number. So I will return what? 17. Hope you understand this. Now, how to answer this problem? First of all, we want to traverse the matrix. Then, what is the second step? In second step, we want to find what are the prime numbers in it. Before that, we want to find whether it is a diagonal or not. And then we want to find whether it is prime or not. If it is prime, we want to take the maximum, right? And what is the third step? We want to return the maximum. That's it. So these are the 3 steps involved in our basic approach, right? Can you understand this? Okay. Tell me about something. How we can just derive the diagonal? Okay, how we can get the diagonal elements? Okay, fine. Let us take this matrix as an example. So 0, 1, 2. Here also 0, 1, 2. So I will traverse from 0 to 2. I value as what? 0 to 2. And if I take nums of I and I will take 0, 0, 1, 1, 2, 2. So I took a 1 diagonal. Now, if I take nums of I, then length minus 1 minus I, which means first I will be at this 0, 2, then 1, 1, then 2, 0. Right? So this is how we want to find the diagonal. Okay. One step is finished. So we finished for diagonal. Now it's time to finish the prime numbers or not. Okay. How to find whether the number is prime number or not? Okay. It is so simple. We want to traverse from 2 to square root of that number. Okay. If there exists any factor or if there exists any number that divides that given number, then we can say what? It is not a prime. Then it is not a prime. Can you understand this? If all the values between 2 and the square root of that number cannot divide that number completely, then we call it as what? Prime. Then we want to take the max and return the max. Okay. Now, what is the time constant in space entry for this solution? I can say my time constant will gonna be like O of n because we are traversing n times for the diagonal elements, and also into we are just going up to what? Square root of that largest prime number. So let us take largest prime number as m. Then it will be n into square root of m. And what is my space const? It is O of n. So this is my time and space const. Can I understand this? Okay. So it is what? A simple brute force solution. Now we want to optimize it, right? So how can we optimize it? We have any idea like how can we optimize it? Yes, we have an idea like we use a sieve method to find what are the prime numbers present in the given value. Yeah, up to the range. Okay. If, take for example, we want the prime numbers in a range of 0 to 25, then we want to construct an array, initialize all values as 1 of size 26, which ranges the range from 0 to 25 as an index. Okay. Now, initially I make this 0 as 0 and 1 as 0 because 1 and 0 are not a prime, right? So they will be not a prime in case of 0. Okay. Now, 2. So 2 is prime, right? So 2 multiples cannot be a prime. So I will make this 4 as 0, 6 as 0, 8 as 0, 10 0, 12 0, 14 0, 16 0, 18 0, 20 0, 22 0, 25 sorry 24 also 0. Okay, now I'll go to the next value. It is 3. 3 is 1, right? Third index is 1, which means 3 is a prime. 3 is a prime. So I will make 3 multiples as a not prime. Okay. Now 6 is already marked as 0. So don't do anything. So 9 will become 0. 12 already marked. 15 will become 0. Then 18 is already marked. 21 will become 0. 24 is already marked. Okay. Now going to the next index. Now see this fourth index. Fourth index is 0, which means what? It is already not a prime. Okay. Just move on. Just move on. Now it is a fifth index. Okay. For fifth index, I want to mark this what? This 10. 10 is already marked. 15. 15 is already marked. 20. 20 is already marked. 24. Sorry. 25 is not marked. So I want to make this as what? 0. Hope you understand this. Now let us go for the next value. What is the next value? It is 6. 6 index is already what? Not a prime. So go to the next 7. So 7. 14 is already marked. And 21 is already marked. Okay, fine. Fine. Don't worry. Go to the next iteration. Okay. Now it will be next it will be 8. No, it is not a prime. It is also not a prime. It is also not a prime. Now it's time for what? For 11. For level. Now 11 multiple is 22, right? So 22 is already marked as what? 0. Okay. Now then again go further. Go further. If we go further, it will be 12. 12 is already not a prime. 13. 13 is a prime. But what is the 13 multiple? It is 26. 26 out of range. Okay. So stop here. Stop here. Okay. The first observation is whether we done anything apart from this 5, apart from this 15 this, whether we have done anything, any modification. No, right? No, we haven't done anything. So we want to traverse from 0 to square root of n. First step. Okay. Then second one is, let's observe carefully. For 2, where I am started to making 0 from 4. For 3, where I am started, 6 is already marked. So I will go for what? 9. For 2, I started with what? 4. For 3, I started with what? 9. And 4, for 4, I started with from what? 16. Right? Because 8 and 12 is already marked. So, sorry. We cannot take 4, right? Then 4 Next, we will take 5. For 5, what are the things we have took? First, 10. 10 is already marked. 15 already marked. 20 is already marked. So 25. So 25 we mark. So from this observation, I can say that we are just starting from what? Starting from the square. So if it is I, then we will start from what? I into I, 2 up to n. Then I will increment up to what? I. So this is the second condition. Can you understand this? Okay. Okay. When I should do this? When the number is prime. When I is prime. When I is prime, I want to do this. Can you understand this? Okay. By doing this, we can take what is the maximum number. What is the maximum number present in the diagonal, which is also prime. Let us see the code so that it is more clear. See here, this is a code. N is equal to length of the nums. Then I'm just traversing through this entire matrix and finding what is the largest possible value I can get in a diagonal. Okay. And I'm just taking that in my prime array cells. Can you understand this? Here I told you how to find the prime number or not. Now it's time to do what? This is my matrix, right? This is my matrix. Inside this matrix, I'm just traversing all these diagonals and taking the maximum value among this diagonal. And I'm going to construct a new prime array for that diagonal 6. Okay, that's what I have done here. Now, prime of 0 and 1 will be made as what? 0. Now, I'm just traversing from what? 2 up to what? Square root of that number plus 1. Which means, see here I wrote 0, right? It is wrong. It is 2 only. Why? Because see here already 0 and 1 are marked as what? 0. Which means what? They are not a prime. Okay. Fine. Now, then if prime of I, which means if the current element is prime, then only I do what? I do the multiples of that element into what? 0. So that I am doing the multiples of that is 0. Now, result is equal to 0 for I in range of n and prime of nums I, then I. Then I, okay? Which means what? This type. From the top left to bottom right. Now, if that is max, I will take that as a max. Now, if prime of nums of I, then n minus I minus 1, which means what? It is from top right to bottom left diagonal. So if the diagonal is maximum, I will take that's the maximum. Then I will return the result. Let me submit it. Yes, it is submitted successfully. Now it's time to see the time complexity for this problem. Okay. What is the time complexity and space complexity for this problem? For the second approach, I can say my time complexity will be like over what is the maximum element into log of log m, right? So this is the time complexity for this sieve method, right? Yeah, just iterating to what? To the maximum of what? M into log of m. Sorry. Okay. Now what is the space complexity? It going to be like O of m. M means what? Maximum value. Okay. So this approach is purely of what? Maximum value only. Okay. And also we will traverse, right? So plus O of, for traversing it be n. Can you understand this? So overall time complexity will be what? O of m into log of log m plus n. And what is my space complexity? It is over m, the maximum value. Fine. So this is all about the time and space complexity for this second approach. Thank you.